I'm Mr. Joseph, your chemistry teacher, still on Introduction to Organic Chemistry. We're still dealing with stereoisomerism. This is a typical examination question, chemistry A-level question, AS paper 1 question on Introduction to Organic Chemistry that has to do with stereoisomerism. Now, glucose 6-6-12-O6 is a product of photosynthesis. It has a structure. How many chiral centers does the molecule have? When we talk about chiral center, it has to do with an asymmetric center, which is a carbon atom that is bonded to 4 different atoms or group of what? Atoms. Any molecule that have a chiral carbon is said to be what? A chiral molecule, and it will show optical isomerism, which will form 2 optical isomers that are non-superimposable mirror images of each other, otherwise known as enantiomers. So let's look at the number of chiral centers does the molecule have. This particular word molecule, which is a carbon atom that is bonded to 4 different atoms or group of atoms. So this carbon is not chiral. This carbon is not chiral because it's not bonded to 4 different atoms or group of atoms. This carbon is chiral. This carbon is chiral because it's bonded to H, OH, H, then the whole of this, and the whole of this compound, the whole of this. So this carbon is chiral. So we have 1 chiral carbon. Then the second carbon is chiral. This carbon is chiral because it's bonded to H, OH, is bonded to the whole of this, and is bonded to the whole of this. So it's chiral. We have 2 chiral. See, this carbon is chiral. 3, because it's bonded to H, is bonded to OH, is bonded to the whole of this structure, and is bonded to the whole of this, the entire this. Then this carbon is chiral, which is 4. Because it's bonded to H, is bonded to OH, is bonded to the entire of this, and is bonded to the whole of this. Then this carbon is not chiral because it's bonded to 2 hydrogen atoms. So we have 4 chiral centers in this molecule. So the answer to this question is what? C, which is 4. So we have 4 chiral centers. We have 4 chiral carbon atoms, 4 chiral centers. So it's as simple as what? ABC. Attempt as many questions as possible, and feel free to reach out to me if you encounter any difficulty. I'm Mr. Joseph, your chemistry teacher. I'm always there for you. Please feel free to reach out to me if you encounter what? Any difficulty, and I'm always there for you. Thank you very much. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures. So before us is a typical A-level chemistry question on Introduction to Organic Chemistry, AS paper 1 chemistry question. The question before us is on stereoisomerism, basically optical isomerism. Now, artemisinin is a powerful anti-malaria drug. You can see the structure of artemisinin. You are now asked how many chiral centers are there in each molecule of artemisinin. When we talk about a chiral center, it is a carbon atom that is bonded to 4 different atoms or group of atoms. Any molecule that contains a chiral carbon atom will exhibit what? Optical isomerism. So it's a chiral molecule to exhibit optical isomerism. So which are isomers that are non-superimposable what? Mirror images of each other, otherwise known as what? Enantiomers. So we're going to identify the chiral carbon that is present in this molecule. How many chiral centers are there in each molecule of artemisinin? Now, if you look at this carbon is not chiral. This carbon is not chiral. It's not chiral because it's bonded to what? 3 hydrogen atoms. So it is not chiral. But if you look at this carbon is chiral because it's bonded to hydrogen. Bonded to hydrogen. This carbon is chiral, which is 1. It is chiral because it's bonded to what? CH3, bonded to this, and bonded to this. So this carbon is chiral. This is 1. This carbon is non-chiral because it's bonded to what? It's bonded to what? 2 hydrogen atoms. So it is not chiral. It is not chiral. Then this carbon is not chiral because it's bonded to 2 hydrogen atoms, which is CH2. If you look at this carbon is chiral because it's bonded to this, it's bonded to the whole of this, it's bonded to the whole of this, and it's bonded to what? 1 hydrogen atom. So this carbon is chiral. So you have 2 here. This carbon is also chiral because it's bonded to this, it's bonded to this, it's bonded to this, and it's bonded to this. So you have 3 now. 3. Then this carbon is chiral. So we have 4 here. This carbon is chiral because it's bonded to CH3, it's bonded to this, it's bonded to this, then it's bonded to hydrogen. This carbon is not chiral because it's not bonded to 4 hydrogen atoms, it's only bonded to 3 atoms or group of atoms. So this carbon is not chiral. Then this carbon is chiral, which is 5. This carbon is chiral because it's bonded to hydrogen. It's bonded to this. 2 is bonded to this, is bonded to this. So which is 5 now. So that carbon is chiral. Then if you look at this carbon is chiral because it's bonded to CH3, it's bonded to this, is bonded to this, is bonded to this. So this is the 6th. Then this one is the 7th. This carbon is chiral because it's bonded to hydrogen here, is bonded to this, is bonded to this, is bonded to this. So this is carbon is chiral. So we have what? 7 chiral centers in artemisinin. So the answer to this question is what? C, which is 7. So it's as simple as what? A, B, C. Attempt as many questions as possible and feel free to reach out to me if you encounter any difficulty. I'm Mr. Joseph, your chemistry teacher. I'm always there for you. Feel free to reach out to me. Thank you very much. I'm Mr. Joseph, your chemistry teacher. I'm back with my lectures. Before us, a typical examination question, chemistry A-level question on introduction to organic chemistry. Now, which compound is both chiral and acidic? Well, they identify the compound that is both chiral and acidic. When we talk about a chiral compound, it's a compound that contains a chiral carbon, a carbon that is bonded to 4 different atoms or group of atoms. When we say a compound is acidic, that means it contains a carboxylic acid group. It contains a carboxylic acid. So we're going to identify the compound that is both chiral and acidic. Now, if you look at A is acidic, contain a carboxylic acid group. It's acidic, but there's no chiral carbon there. This carbon is not chiral. This carbon is not chiral. There's no carbon that is bonded to 4 different atoms or group of atoms. So A is not the answer. Now, if you look at B, there's no carboxylic acid group there. So B is not the answer. It might be chiral, it contains a chiral carbon, but it's not acidic. So B is wrong. Then if you look at C, now if you look at C, there's a chiral carbon. This carbon is chiral. This chiral carbon is C, but there's no carboxylic acid group. You look at this is not carboxylic acid. This is an ester. So C is the wrong answer. C is not correct. So now let's look at D. I think D should be the correct answer because D contains what? A carboxylic acid group, and it also contains a chiral carbon. This carbon is chiral. It's bonded to hydrogen, it's bonded to OH, it's bonded to a carboxylic acid. So D is the correct answer. It is both chiral and also what? Acidic. So D is the correct answer. So it's as simple as A, B, C. Attempt as many questions as possible and feel free to reach out to me if you encounter any difficulty. I'm always there for you. I'm Mr. Joseph, your chemistry teacher. Feel free to reach out to me. I'm always there for you. So still on introduction to organic chemistry. So before us, a typical examination question, chemistry A-level questions on introduction to organic chemistry. Alkanes are saturated hydrocarbons. Which type of reaction are alkanes most likely to undergo? So the major reactions of the alkane, A is not the answer. A is electrophilic addition. Alkanes doesn't undergo electrophilic addition because alkanes are saturated hydrocarbons, so they don't undergo electrophilic addition. Then B, electrophilic substitution. Yes, A, alkane doesn't undergo what? Electrophilic substitution. Then free radical substitution. So C is the correct answer. Alkanes undergo free radical substitution. So the correct answer to this question is C, which is the correct answer. D is wrong because alkanes doesn't undergo nucleophilic addition. Nucleophilic addition is aldehyde and ketones that undergo nucleophilic addition reaction. So D is the wrong answer. So the correct answer to this question is what? C. So attempt as many questions as possible. Feel free to reach out to me if you encounter any difficulty. I'm Mr. Joseph, your chemistry teacher. I just want you to know that the major reactions of the alkanes are free radical substitution reaction and combustion reaction. So the answer is what? Free radical substitution reaction. Alkanes are most likely to undergo what? Free radical substitution what? Reaction, which is the reaction of an alkane with a halogen in the presence of what? UV light. Thank you very much. Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel, comment, like, share, and reach out to me if you encounter any challenge or any difficulty. I'm always there for you. I'm Mr. Joe, your chemistry teacher. Subscribe to my YouTube channel. Thank you very much.